Okay, welcome to this RoboCode tutorial. What we're going to be doing today is just looking at some very simple get yourself started code for RoboCode and how we can program our AI tank. So to start us off, I'm going to go to Robots, Source Editor, and I'm going to create a new robot that I am going to call 25. So that's the name of my robot. The package is the folder or collection of robots. So he is just going to be part of a package called Simple Bots, and any kind of simple, kind of low-level bots I'm going to put in this package called Simple Bots. And so that creates my kind of template. There's my name of my robot, and you can see the package is called Simple Bots, the kind of little family of robots. And we're going to have a little look at how this robot works and look at the different areas of code that we can change and affect. So the first area is this run method, which runs from here to here, goes from here to here. So up above the while loop is where we can put in any variables that we want to. So maybe we've got a variable like an integer variable for life, and currently it equals 0, but we're going to update it with our robot's life or the life of our enemies. Maybe it's going to be life enemy. I can spell enemy. So any variables kind of go in that section there. Then below that we've got this while true while loop. So what the while loop does is it repeats itself, and it repeats itself until whatever is in the brackets is not true anymore. So you can have while I is less than 100, and then inside your loop you're like I equals I plus 1. So every time it goes through, it increments, so it's going to do it 100 times. What we're doing instead is we have just said while true is equal to true. So it's always going to be true. It's always going to repeat itself. It's a forever loop. It's just going to keep going and going and going. It will run through these 4 steps for the whole time the program's running. So it runs, it goes to the first line. It says, okay, move the robot ahead 100 pixels, then turn the gun and the radar around 360 degrees, a circle. Then move back 100 pixels, turn the gun around and the radar around 360 degrees again, and then it goes back to the top and goes through that once more. So that's what the while true method does. It's the main loop, and it's where you would put your main code that kind of controls your robot when it's not interacting with other things. So what will jump us out of this while loop is an event, and there are a few different events that happen. One of the most important is this on-scanned robot. So our radar has picked up that there's another robot around us, and it generates an event, a scanned robot event, which is called E. And we can use this E event to get lots of information. Like I can go E.get name, for example, to get the name of the robot that I've just scanned, which is really useful, or well, could be useful. The name's not 100% useful, but you can get lots of other things like its location, how much energy it's got, all of that kind of good stuff. So what happens is when this event occurs, when I scan a robot, I see a robot, this is the code that I run. And at the moment, it just fires a bullet at it, which is a pretty reasonable response. If I see a robot, I'm going to shoot at it. Very good. We've got a few other events as well. So if I get hit by a bullet, so if another robot's seen me and shot at me and hit me, what should I do in that case? So I'm going to have to do some sort of evasive maneuvers. So I'm going to move back 10 pixels. That's a pretty simple evasive maneuver, and we can improve upon that definitely. Another event, we hit a wall. What should we do if we hit a wall? Well, I'm going to move back 20 is a pretty reasonable response. So what I'm also going to do is I'm going to go turn right, let's say 180 degrees. So turn all the way around and move ahead say 200 pixels, so to get us away from that wall. I'm going to save that. The first time you save your document, it will, and this, if your package folder doesn't exist, it will ask you to create it. We go yes, and we're going to save Johnny5 in that newly created folder, and then we're going to compile it. And just compiling it basically means we need to check for errors and convert it to code that the computer can read. So we compile it. It's compiled without any errors, compiled successfully. We can click OK, and now we should be able to use this robot in our battles. So now we've compiled our code, I'm going to come up here to battle, and I'm going to create a new battle and choose the robots that I would like to add into it. So you can see here we've got a little selection of robots. So I've got another folder of robots of my own, some sample robots that come with RoboCode, and there's my simple bots package that I just made in my robot. So I add him in. I'm going to add a couple of other robots in there as well. This one's sitting duck, as the name implies. He just kind of sits around and does nothing much. Walls has got an interesting tactic. We will see what he does, but we're interested in what Johnny5 is going to do most of all. So I click start battle. Now at the moment it's moving quite fast. I'm just going to slow it down a little. So there's Johnny5, and at the moment he is following our code. He's moving ahead. 100, scans around looking for robots. He saw one, so he shot at it, and then he moves back. 100, scans around, sees a robot, shoots at it, and then moves ahead again. So that's what he's doing at the moment. And as you can see, he's not doing too well at the moment. But yeah, we're at quite simple stage. So I'm just going to stop that, and we're going to go back to our code. So let's start improving our robots. So the most important event that happens is this event here, the on-scanned robot. We want to do something when we see a robot we can fire, but I'm going to do something slightly more sophisticated. I'm going to get the distance. I'm going to make a variable, and it will be a double variable, which is a kind of 1.23 or something like that. So it's going to be double dist equals e.get distance. And I put brackets in to indicate that it's a method or function. So what happens is it uses the e from the event that's been passed in. So this gets the details of the robot that we've scanned, and it can get the distance between us and the robot. So that's quite a useful little thing, and I'm going to store it in a variable called dist, short for distance. I mention at this stage the RoboCode API. So this is all of the code that already exists to help us do our robots or make our robots. So if you go to the RoboCode Java API, these are all the kind of things that we can look at. And you remember at the top of our code, it said it extends class robot. So if we click on robot, this is the class robot and all of the kind of methods, functions, and little bits and pieces that we're getting. Okay, so when we extend that class, we get all of these functions. So we get the ahead function that we've been using, the back function that we've been using, the fire function we've been using, and lots of different things. So we can get the name of our tank, we can get all sorts of things like the round numbers, we can get our X and Y position, and that kind of thing. But down the left hand side we also get a number of events, the most important of which was the scanned robot event. So we can see what kind of thing we get in that event that's passed to us. So if I just remind you of what that is. So on scanned robot, we get the scanned robot event, and it's called E. That's the variable name. On that scanned robot event, we get all of these rad little things like the get distance, which is a double. Yeah, so that's going to be like the 1.23 or the 5.75 or whatever. The energy of the robot, the heading of the robot, that's the direction it's going. We can get its life. No, we can't. That's deprecate. We use get energy instead of that. We can use get name and all of these kinds of things. Where it says deprecated, it means you should use another method instead. It's been superseded, essentially. So these are all the things that we can use these are all the things that we can get, or the information we can get about the other robot that we've just seen or that we've just scanned. So we used our variable distance to store the get distance of the other robot. And what I can do is I can go if dist is greater than 100. So if it's bigger than 100, I want you to do this code, and I want you to let's go fire 1, so you can fire a bullet at it with power 1. Else, if dist is less than 100, I want you to fire. So if we're a little bit closer, we're going to use a more powerful bullet. We probably always also want to say if it's less than or equal to, because if we don't include that, if it's greater than 100, that's good. If it's less than 100, that runs here. But if it's exactly 100, then we've got a bit of a problem. So we go less than or equal to. So if it's less than or equal to 100, we're going to fire with a power of 2. Also, if we're less than or equal to 100, I'm okay with our distance from the robot. Yeah, we're nice and close. But if we're quite far away, I would like to move ahead, and let's say distance times 0.5. So I'm going to go half the distance to the robot and close that gap a little bit, just to get a little bit closer so my bullets have more chance of hitting, because he'll have less time to move away. So I'm starting to see that I can get a bit of strategy going using the code. Well, now that we've changed our robot's tactics a little bit, it's time to see and test how he's doing. But before we do that, I'm just going to do one more thing that's really useful for testing, and I'm going to print out to this little console the distance that we're getting. So I'm going to go distance equals, and then plus to separate the two things, and I'm going to go dist. So what this does is it uses a system class and prints a line which has the string distance equals, and then the distance that I'm getting here, the variable distance, the value that's stored there. So I'll save that, and I'm going to compile it by going compiler and compile. You can see Command B also. So compiled successfully, no errors. So it should be available to me for a battle. There's Johnny 5 sitting duck and walls. So let's start that battle and see what happens. And if I click on Johnny 5, it brings up his console, and you can see it's printing out the distance. So there's Johnny 5. Let's have a look at what he's up to. So he's scanning, he gets the distance, it's 200 away from walls, but he's not moving in the direction of walls. Every time he scans a robot, he seems to be just moving ahead, which is what we told him to do, but we didn't think it through. So as he scans a robot, he just shoots at the robot, but moves ahead. And now he's moving back, he's just in his normal kind of frame of reference, and yeah, it scans a robot and moves ahead. So we really should have moved him toward sitting duck or toward walls when he scans them. At the moment he's just moving ahead the way that he's facing, which is a bit of a problem. So we're going to have to fix that. And in order to do that, we're going to do some mathematics. It's simple mathematics, but it's, it's nothing too crazy hard, but it's a little bit difficult and can be a little bit challenging. So we're going to talk through it nice and slowly, and we will get through it. Okay, so here is our diagram to help us with the mathsy side of things. So what we're going to talk about first is the idea of hitting. So we have body hitting, we have gun hitting, we also have radar hitting, and that's going to have a value. Let's make that a little bit bigger. Okay, so the body hitting is the direction in which the body is facing. Yeah, and if you haven't changed the radar and gun position, that'll be the way they're facing as well. They start aligned to the body. So 0 degrees is straight up, 90 degrees we're working clockwise to the right, 180 degrees, 270, and then back, 360, come to 0. Okay, so that tank right there is at a 0 degree heading. If I rotate that tank, he's now at a 90 degree heading. He's heading in the direction of 90 degrees. Yep. Rotate him again. He's at 180, or maybe actually that was a slightly odd rotation, so he's at like 175 or something like that. But what I can also do is I can rotate the gun and the radar individually as well. So that's what happens there is, let me do this properly. The gun rotates to, say, that position to shoot at something. So the body hitting at the moment is equal to what? It's equal to 0. The gun hitting is slightly different, and that is equal to 45. Yeah? The radar hitting hasn't been shifted and is still equal to 0. So what we need to understand is sometimes these things will differ. So when I rotate this, when this rotates around, now the body hitting is set to what? 45. Gun hitting 90. Radar hitting also 45. Okay, so sometimes, for example, if in our scenario before, the radar and the gun were rotating around and they scanned a tank. Okay, they scanned a tank, and this tank was over here. Okay, there's my enemy tank. So the gun and the radar are pointing at the enemy tank, but the body is at heading 45. So when we typed in the command, and I'll type it in just so you can see it, when we typed in the command ahead 100, or we did ahead distance times 0.5, that was our command. A little bit bigger. Yeah, it moved in this direction. Yeah, it moved in that direction. Instead of moving toward the tank, which we kind of wanted it to, we moved in the direction that the body was facing. So what we need to do is, before we just go ahead distance times 0.5, we probably need to rotate the body to what is called to the radar heading. So we can update the body heading to match whatever the radar heading is doing. So let's have a look at how we do that.